last thing we're going to do in this particular part of the unit is to solve equations using square roots. Now, we have talked about squares, like 3 squared means 3 times 3, which is 9. So we always have operations in math that undo other operations. The square of a number is a product of a number itself, so I said 3 squared is 9. The square of 6 is 6 squared, which is 36. A square root undoes a square. So the square root of a number, the square root of 36, is both 6 and, this is important, negative 6. Because I say, what numbers could I square? What number could I multiply by itself and get an answer of positive 36? Well, positive 6 times itself is positive 36. And negative 6 times itself is also positive 36. I don't always need both of those answers though. So when I'm looking at square root symbols, the basic square root symbol looks like this. And if it just says this, the square root of 36, the answer is positive 6. If it has this, it's asking for both the positive and negative square root of 36. So my answer would be negative 6 and positive 6, which is written a lot of times like this. This means both positive and negative 6. And if they only want the negative root, then they would write it this way. So it depends on what they're asking. If I'm solving a problem and they say simplify this, the answer is 6. Often though, when we are actually solving equations, this equation says the x is my unknown. So what number or numbers could I multiply by, what number or number could I multiply by itself and get an answer of 81? Well, I have two possibilities. I could multiply negative 9 by itself and get an answer of 81. Or I could multiply positive 9 by itself and get an answer of 81. So when I solve equations with the variable in here, the way that I undo the square on this side is to square root. So the square root of x squared is going to give me x. But I need to look at both the positive and negative square root of 81. Now, because this is a new symbol, I want you to give your answer as x equals negative 9 and x equals positive 9 instead of this symbol, because I found right now that if I let students use that symbol, they don't always totally understand what that means in their answer. So two different solutions for these answers. When I see a square on the x, I'm expecting up to two different answers. What we're really doing in this case is if I were to graph a y equals x squared kind of equation, I get a parabola. It looks kind of like a U or an upside down U. What we're saying is if I graphed the parabola y equals x squared minus 81, this would cross the x-axis at negative 9 and at positive 9. And we're going to be solving for those kinds of solutions later. But just so you know, that's where we're eventually going. I can't square root this side yet because it's got this plus 5 here. So the first thing I'm going to do is subtract 5 from both sides to get x squared equals 49. Now, I'm not going to show this square root sign on the left anymore. I'm just going to say the way that I undo this square is to square root, but I do need to show the positive and negative square root of 49 part on this side. If you'd like to show this symbol with the square root of x squared here, please feel free to do that. So x equals negative 7 is one of my solutions. X equals positive 7 is the other solution. Again, x squared, I'm expecting most of the time to get two different solutions. Again, I'm not going to square root this side yet because the x squared isn't by itself. It's connected to this 3 with multiplication. So the first thing I'm going to do is to divide both sides by 3 to get x squared equals 25. Square root the left to get x, and I need to find both the positive and negative square roots of 25 for my two answers. So x equals negative 5 is one of my solutions, and x equals positive 5 is my other solution. They are not always negative 9, positive 9, negative 7, positive 7, etc. When you get into problems like this, where the thing that's being squared is inside parentheses, well, the way I undo the square is to square root. So x plus 3, square root that side, I have to look at both the positive and negative square roots of 4 on the other side. So x plus 3 equals negative 2 is one equation I'm going to set up because the negative square root of 4, and x plus 3 equals positive 2 is my other equation. Again, the negative 2 and positive 2 came from both the positive and negative square roots of 4. Now when I solve this equation, I'm going to subtract 3 from both sides. I get x equals negative 5 on this first one. Subtracting 3 from both sides here gives me x equals negative 1. So I don't always have opposites for my answers like I did in the first one, negative 7 and positive 7. Now, because the thing that was being squared was inside this parentheses and had addition or subtraction in there, I get answers that are not opposites. Well, I want to get the thing that needs to be square rooted on one side by itself. So the thing that's being squared has to be on one side by itself before I can square root, which means I don't want this 4 in front of the parentheses and I don't want this plus 7 afterwards. I can't distribute the 4 because of that square on the parentheses. So the first thing I'm going to do is to subtract 7 to get rid of that. So I have 4 times the x minus 5 quantity squared equals 144. Again, I can't distribute to get rid of that 4, but now I can divide both sides by 4 to get the thing that's being squared by itself. The x minus 5 squared is by itself on one side, and then 144 divided by 4 is 36. Once the thing that is being squared, the x minus 5 being squared by itself, now I can square root both sides. The left becomes x minus 5. The right becomes both the positive and negative square root of 36. Well, the square root of 36 is 6, so one of my equations is x minus 5 equals negative 6. To get that negative square root, the other equation is x minus 5 equals positive 6. I'm going to add 5 to both sides to solve these equations. So x equals negative 1 is one of my solutions, and the other side, x equals positive 11. So those are my two solutions. Now, before you come to class tomorrow, solve this equation using the method that we just looked at.